All right, happy Tuesday. Today we will be looking at lesson 10.3, adding and subtracting radicals. Again, please open your packets to page 12 and fill in the title box. Like radicals are radicals with the exact same expression under the radical symbol. So for instance, the square root of 2, 5 square root of 2, negative 7 square root of 2 are all like radicals because they both have a 2 underneath. Unlike radicals are radicals with different expressions under the radical. For an example, square root 3, 5 square root 2, 8 square root 7 are all unlike radicals. The difference is a like radical can be combined together using addition or subtraction. Unlike radicals cannot be combined and must remain separated. It is very similar to like terms with variables. So adding and subtracting radicals, basically we have a three-step process. Step 1, if there are any like radicals, add or subtract the numbers in front of the radicals. Keep what's under the radical the same. For example, 2 root 3 plus 4 root 3. They both have a square root of 3, so they're like radicals. We take the 2 and the 4 and add those together to get 6. The radical doesn't change. Again, just like a variable when we're adding and subtracting like terms. Step 2, simplify the radical completely by either using a factor tree or the perfect square method. And then step 3, if any of the simplified radicals are like radicals with other terms, combine them. Keep all unlike radicals separate. So in our example from step 1, we cannot simplify the radical, so 6 root 3 would be our final answer. All right, so here we go. Some adding and subtracting of radical expressions. We have 7 root 2 minus 12 root 2. Both have a square root of 2. So our answer is going to have a square root of 2, and they can be combined. 7 minus 12 is negative 5. Negative 5 root 2 would be our simplified expression. The square root of 2 cannot be simplified any further, so our problem is done. Example B, we have 4 times the square root of 3x plus the square root of 3x minus 2 times the square root of 3x. So each term has a square root of 3x. So our answer is going to have a square root of 3x. One thing to be careful of here, this middle term has a 1 in front of it. So we're going to add and subtract, working from left to right. We do 4 plus 1, 5, minus 2 is 3. Last thing, we check that radical, can it be simplified? And 3 times x is as simplified as that will get. So that's our final answer. Letter C. We have 6 root 45 minus the square root of 45, or minus 1 square root of 45. So we have the square root of 45. We take 6 minus 1, that's 5. Can we simplify the square root of 45? Let's look at this using the factor tree method. Let's see, 45, does 2 divide evenly into 45? No, because 45 is not even. So then we check 3. Does 3 divide evenly into 45? If you remember the rule, we add the digits together. 4 plus 5 is 9. 3 does divide into 9, so 3 divides into 45 15 times. Does 3 divide evenly into 15? Well, again, 1 plus 5 is 6, which is divisible by 3. So 3 divides evenly into 15 5 times. So the square root of 45, we've got that pair of like factors, 3. So we bring a 3 outside of the radical. We have this unpaired term 5. So we get 5 times 3, which is 15, times the square root of 5. All right, try now. So go ahead and simplify this expression completely. We have a square root of 10 in all of our terms. So we're going to have a square root of 10 on our answer. We're going to take 2 minus 1, which is 1, plus 9. 1 plus 9 is 10. And the 10 under the radical, and we could try to factor it if we wanted to, 2 and 5. But we don't have any pairs of factors that are the same, so we just leave it as 10 root 10. All right, a few more, excuse me, to do. 4 root 6 plus 5 root 2 minus 2 root 2. So these two have the same radical, so we can combine those. So we have 5 minus 2 for 3 root 2. The 4 root 6 does not have a like radical to combine with, so we write that separate. And then we should check to see if we can simplify any of our roots. 6 is 2 times 3, so that doesn't have any perfect squares that can be pulled out, so that's as simplified as it is. And 2 is prime, so that cannot be simplified. Example B, we have the square root of 5 plus the square root of 24 minus 4 times the square root of 5. So again, square root of 5, square root of 5. 1 minus 4 is negative 3 square root 5 plus the square root of 24. 5 is a prime number, so it cannot be simplified, that root. 24 is not a prime number, so we can try to simplify that. I'm going to try the perfect square method for this one. So 24 is not a perfect square, and 16 is the largest perfect square, less than 24. So I checked, does 16 divide evenly into 24? The answer is no. Then I try 9. Does 9 divide evenly into 24? No. So then I try 4. Does 4 divide evenly into 24? And the answer is yes. So the square root of 24 is the square root of 4. And 24 divided by 4 is 6. I have negative 3 root 5 plus the square root of 4 is 2. Square root 6. The letter C, we have a whole bunch of terms. So we're going to take them one at a time. And usually, now that the first example, we didn't do it this way, but usually we want to write these things with the radicands in increasing order. So we have a square root 5, a square root 2, square root 5, a square root 2, and a square root 7. So we have 3 different radicands. So if we start with the square roots of 2, we have negative 7 plus 3 would be negative 4 root 2. Then we go with our square root 5. Seven minus 4 is plus 3 root 5. And then the square root of 7, we just have the one term that has a square root of 7, so minus the square root of 7. 2, 5, and 7 are, all 3 of them are prime numbers, so we cannot simplify any further. That would be our final answer. Go ahead and try the try now on page 13, and we'll take a look at the answer here in a minute. Like radicals with the square root of 3. Like 1 square root 3 minus 11 square root 3. 1 minus 11 is negative 10 square root 3 plus the square root of 20. 3 is a prime number. That root cannot be simplified. 20, we can try the factor tree method. 2 divides into 20, goes in 10 times. 2 divides into 10 5 times. 5 is prime. So we're going to have a 2 that comes out of the radical and a 5 that stays underneath. Sometimes we're going to have variables underneath our radicals. And there's a very easy way to simplify them. If we have x squared underneath a square root, that's the same as x. Y to the 4th underneath the radical is the same as the square root of y squared squared, which would be y squared. The square root of x to the 10th is equal to x to the 5th squared. When we take the square root, we get x to the 5th. Y to the 16th then. I like to do it this way. If it's a square root, is the exponent even? In this case, 16 is. So we're going to have y outside of the radical. take our power and divide by our index. In this case, the index, remember, is a 2. 16 divided by 2 is 8. And that would work for all of the previous examples as well. X squared, 2 divided by 2 is 1, so you get x to the first. Square root of y to the fourth, 4 divided by 2 is 2, so you get y squared. Square root of x to the 10th, 10 divided by 2 is 5, you get x to the 5th. What happens if we get a variable that doesn't have an even power, like x to the 7th? Then what we're going to do is write x to the 7th as x to the largest even number that's less than 7. So 6 is even and less than 7. And then we're going to get a square root of x multiplied by it. The square root of x to the 6th simplifies into x cubed. And we have that square root of x left. So if the power underneath the square root is odd, you're going to end up with a square root of the variable. This next example, y equals, I'm sorry, the square root of y to the 13th. The largest even number that's less than 13 is 12. So we have a square root of y to the 12th times the square root of y. The square root of y to the 12th. 12 divided by 2 is 6. Y to the 6th times the square root of y. An even number of variables can always be taken outside of the radical. So again, that's that even power. When simplifying, you should never leave a variable under the radical with an exponent greater than 1 when you have a square root. If an expression contains both numbers and variables, separate and simplify each part separately. So the square root of 20, x to the 10th, y to the 5th. Write that as the square root of 20 times the square root of x to the 10th times the square root of y to the 5th, and simplify. The number portion can be simplified using either a factor tree or the perfect square method. The variables will be simplified like we did right above on this problem. If you want to know, yes, this does simplify into 2 root 5. And then we would have x to the 5th, y squared, square root y. So we would rewrite that all together. 2x to the 5th y squared times the square root of 5y. So here we have a couple to work on. The square root of 40 x to the 6th. So we're going to try to simplify the square root of 40. X to the 6th. 6 is even. So we will not have x to a power underneath the square root times the square root of x. It's just going to be the square root of x to the 6th. We'll simplify that in a minute. With 40, we can use the factor tree method. 2 divides evenly into 40 20 times. 2 divides evenly into 20 10 times. 2 divides evenly into 10 5 times. 5 is prime. So that 40, we're going to get a 2 outside and 2 times 5 inside. 2 times 5 is 10. The square root of x to the 6th. 6 divided by 2 is 3, so that's going to be x cubed. So we get 2x cubed times the square root of 10. Example B. We have the square root of 18. M to the 10th. 10 is even, so I'm just going to write that whole thing underneath one radical. N to the 7th. 7 is not even. The largest number that's the largest even number that's less than 7 is 6. And we're going to have an n left underneath the radicals. For 18, we can use the perfect square method. 16 is the largest perfect square that's less than 18. Does 16 divide evenly into 18? No. 9 is the next largest perfect square. Does 9 divide evenly into 18? Yes. So 18 is the square root of 9 times the square root of 3. We have square root m to the 10th, square root n to the 6th, square root n. Square root of 9 is 3. We have the square root of 3. Sorry. Boy. Nine divides into 18 twice, not 3 times. The square root of m to the 10th. 10 divided by 2 is 5, so we have m to the 5th. The square root of n to the 6th. 6 divided by 2 is 3, so that becomes n cubed outside. And then we have this other n, and we write that underneath with the 2. Another one here. We have the square root of 32. A to the 11th is odd power. The largest even number less than 11 is 10. B to the 19th, 19 is odd. The largest even number less than 19 is 18. We'll have a square root of B there. C to the 2nd, 2 is even, so we just leave C to the 2nd like that. All right. Factor tree for 32. Twice would be 16. 2 divides into 16 8 times. 2 divides into 8 4 times. 2 divides into 4 twice. So we have one pair, another pair, and a factor without a pair. So let's see, 2 times 2 is 4. The square root of a to the 10th, 10 divided by 2 is 5, so we get a to the 5th. And we have an a that goes underneath the radical. Square root of b to the 18th, 18 divided by 2 is 9. And we have a b that goes underneath the radical. The square root of c squared, c divided by 2 is 1, so we just have a c there. And that's our simplified expression. So here's a try now. Simplify the square root of 50 y to the 8th. Rewrite this. Square root of 50. Y to the 8th, 8 is even, so we leave that underneath the square root. Perfect square method. Largest perfect square less than 50 is 49. 49 does not divide evenly into 50, so we check 36. And 50 divided by 36 does not come out even. The next perfect square is 25. So 50 is the square root of 25 times the square root of 2. Y to the 8th, take the square root. So 8 divided by 2 is 4, so we get y to the 4th. The square root of 25 is 5. Y to the 4th times the square root of 2. So there's an introduction to adding and subtracting radicals. We'll do more with this tomorrow. Enjoy, work hard on your homework, and we'll see you tomorrow.